So thank you for the nice introduction. I'm part of the evangelism team in AWS, so we try to help new customers and AWS customers understand the potential of the cloud, what they can do, how it can change their business. And serverless is one of the things that I really think it's interesting right now. There are actually three things that I think we should, as technical people, look after now. One is serverless, because it's changing the way we are creating new applications, and it's already there. Then there is the Internet of Things and edge computing that I think is going to change the way we live, the way we work in the next few years. And there's also artificial intelligence and machine learning. This is a huge trend that is coming, that is probably going to change almost everything. It will be like the Industrial Revolution in the 19th century. So I think these are three trends that we should look after, because it's really where there is interesting potential coming. But let's stick with serverless. So I joined AWS 5 years ago. It will be 5 years in June. So it was quite a different landscape. Cloud computing was not so broadly famous like it's now. And one of the first things that I did was writing a shared file system on top of S3. I put it on GitHub as an open source, and this created lots of interest. Then when AWS Lambda was out, I created a small piece of code to manage authentication with AWS Lambda function. It was like more an example code than anything, but it was very popular. It still is popular. And this gave me some visibility. And then I was approached by Manning, the publisher, and they asked me to write this book. And I brought here a copy today. So the best question today will get a free copy of the book. So ask good questions. And if you need to buy, don't buy it full price. There is this discount that is always valid, only on Manning, not on Amazon. And it's 39 as the discount and my family name. So just to let you know. And more recently, I worked with Manning to create this free ebook. So this is free, and you can download it. It's a collection of content from Manning books that can help you understand how to start with serverless in the right way. Also understanding how web APIs work, and also how to set up an agile development pipeline so that you can be agile and release frequently your updates. So this is free. You can just go on the Manning website, and if you can find it, just ping me. Happy to give you the pointer. But today we're talking about serverless, and what changed everything was 2.5 years ago when we launched AWS Lambda. With AWS Lambda, you can give us your code, and you can create functions. You don't need to manage the servers. You can use these functions one time per month or 1,000 times per second. We will scale the infrastructure for you. You only will pay for what you use. You pay for the number of invocations and the hundreds of milliseconds of execution time. So it's really fine-grained billing. And there is a huge free tier for all customers. So this free tier doesn't expire after the first 12 months, like other free tiers that we have. It's always there for new and old accounts. So every month, the first 1 million times you call a function, you call all your functions, of course. And the first 400,000 gigabyte seconds are for free. So 100 million of requests is easy to understand. Gigabyte seconds is more a strange concept. It means that when you create a Lambda function, you can give some memory to the function. If you give 1 gigabyte of memory, you have 400,000 seconds, so it's a lot. If you give half of the memory, you get twice the time, because this is proportional to the memory. So if you give, for example, 128 megabyte is the smallest amount of memory that you can give. It's 1/8 of 1 gigabyte. You multiply this by 8, it's 3.2 million of seconds every month for free. And according to our estimations, you can create a startup and have a few thousand users, sometimes even a few tens of thousands of users, without any cost from AWS Lambda. So it's perfect for a new startup, or if you are a company and you want to start something new, you want to do a prototype, you don't know how much traffic there will be, you can use this, and basically the only cost will be your own time and the time of the people working on the project. And as I said, with Lambda, you can create these functions, and then they will be there, the high availability, the scalability, it will be managed by AWS with all our expertise. these functions will not run on a single server. They will be managed by our global infrastructure. So you choose a region, like in Europe, you can choose Ireland, Frankfurt, London. Next year, we are going to open a new region also in Stockholm. And every region has multiple data centers. And this function availability will be automatically distributed across multiple data centers. So something that if you want to build on your own is not that easy to do. So it's really reliable and scalable. And when you build a function, you can use it. So just to give you an example, let's create our first function. So normally, the first thing that you create with a new platform is the classical hello world. But since these are functions, you want to pass a parameter and get an output, I extended the concept with greetings on demand. So you give your name and you get your own personalized greeting with your own name inside. All the examples that I will do are on this GitHub repository. So you can go there and grab them and play on your own time. There will be no cost because unless you use this example more than 1 million times in a month, you should not have any cost. So the first thing that this is the AWS console, the new one. Since now we have lots of services, we created a more streamlined interface. And in the compute section, we have Lambda. So I can try to zoom a little bit more, but usually in my experiences, when you zoom too much, JavaScript fights back, and then you don't want. So let me know if you can see something in the back. We also have a couple of seats here in the front. So I go on Lambda. Here you can choose the region, so this is Ireland, and you can create the new Lambda function. We have a few blueprints, so if you want to create a new function, you can start using our blueprints. For example, if you want to trigger a function every time someone is uploading a file on an Amazon S3 bucket, something that is quite common, you can just go here on the filter, write S3, and you find some examples in Python or in Node.js, so some starting code to use. For now, there's also more complex and interesting code. Like we just recently released Amazon Lex, is a chatbot engine with lots of artificial intelligence. You can just write Lex, and you see some example of how to integrate with Lex using Lambda functions. So for now, I will start with a blank function. And then you can choose what kind of trigger you want to use. So when you create a function, usually you need a trigger to launch the execution of the function. For now, I'm not using a trigger. Let's just create a function in the cloud. Let's give it a name, greetings on demand, a description. Description is an interesting field because it's just a free text. You can use it just for your own memory, but you can even use it programmatically because you can read the description using the API. So you can create your own syntax to store information. So if you have lots of functions, lots of microservices, having some way of doing discovery, search of parameters, what is expected. So you can use this programmatically in some way. It's just free text. So for now, I say just say your name and get an hello. Then you can choose the runtime. So the runtime is which programming framework you want to use. So we started with Node.js, so JavaScript server side. Now we recently updated Node.js to version 6. It was one of the most frequent requests. The second top request was to have Python 3, and we released that 3 weeks ago, something like that. So now Python and Node.js are really well updated. Then we have Java 8. Java 8 means that you can upload anything that runs on the Java virtual machine. So if you have more exotic languages running on the Java virtual machine, such as Scala, Clojure, that works. Just upload the jar. You have to respect the syntax. More recently, we also launched C#. So if you come from a Windows environment, you can run your C# functions in the cloud. This edge thing here, for now, let's keep it on a side. Towards the end of the presentation, we will see it's something slightly different than normal Lambda functions. It's still in preview. So I'm creating a Node.js function. I use Node.js 6. And then we have an online editor. Of course, we don't expect you in production to use the online editor. It's more for prototyping, playing. Everything that you do with AWS, you can use command line interfaces, tools to automate what you do. So probably you will never do this in production, but it's cool for playing around. So I have the source code here. This is the basic function. Let's paste it. And then let's look how this works. So this is a little piece of JavaScript. And what we do, we have a function here. And this is the function that we are going to export as Lambda function. Normally, if you upload your code, you can have hundreds, thousands of functions in your code. So you need to choose which one you want to export. And this will be the one that will be invoked by Lambda. You see there's some code before of the function here. That's because the way we work with Lambda. So when you create a Lambda function, we will create a Linux container for you for the execution of the Lambda function. The first time you execute the function, all the code will be executed and the function. But the next invocation will only go through the function because the container is already there. We will reuse the container. So if you have some initialization code, like you need to load configuration parameters, do some computation, or you want to connect to a traditional database such as a MySQL, a Postgres, do that here so that the connection, everything you do will be reused by the invocation. If you put a database connection here, then if you have 1,000 of invocation, you have 1,000 of connection to the database, and that will not work at all. Here's the function, and the Lambda function gets these two input parameters. The event is what the trigger is giving to the function, and it's the way you pass input parameters. Then you have a context that tells you what's happening in the execution environment of the function. So you don't have access to the server, but the context gives you some information. And since this is JavaScript, so this is only for JavaScript, you also get a callback. Callback is some way that it's very common to use in JavaScript to terminate a function and give back an error or a result. But in Python, you will not have a callback, for example. Then I'm logging something. I'm logging the input event. I'm creating a name variable. If there is a name in the event, I take this name in input. Otherwise, if there's no name, I use word as default. And then I build a simple greeting, hello plus the name. So hello world or hello and the name that I pass to the function. I log it, and I give it back using the callback. So the callback syntax, this is standard JavaScript. The first parameter is the error. Null means no error, so it's OK. And then the second parameter is the return value. So I return the greeting. So this is a very, very basic function. And you notice that I'm logging something. So when you log, normally you write to a file, and then you need to connect to a server to read the logs. Here you can't log to a server. So we will automatically collect all your logs and put them in another service that is called CloudWatch Logs. So we already do log collection for you. Here's other option. So environmental variables is a new feature that we launched last year. So if you have some parameters in your function, like the database user and password, that's probably different between test and production, I hope. And you don't want to have two different functions. So you can use environmental variables here to configure a variable with a value and reuse the same code with different environmental variables. And this will be seen inside the code as normal environmental variables. So in JavaScript will be process.env. Here you tell the handler, so which is the function inside the code that you want to export. So we call it handler. So we have to use the same name here. And since I'm using the console, there is a single file. And by default, we call it index. But you can also upload a zip file with lots of files inside. You can also bring your own binaries within the zip file, by the way. So the syntax here is file name without the extension. So index.js means just index dot the function name. So if you have a main.js, for example, and your function is called myFunction, you have the main.myFunction, for example. Then you need a role. Role is a way to give permissions to what the function can do on AWS. And do you think we need a role to execute this very, very basic function? Yes or no? So who is for no? Who is for yes? So there's lots of, so we actually need a role because we are already using another service here. You remember when I was talking about logging? We are writing logs and we collect the logs. So you need some permission to do that. Otherwise, anybody here can log on my account, and probably you don't want. So there is a basic role for Lambda function that will give you permissions to write logs in your own write account. And then if you need to write on an S3 bucket, that's an object storage, or read from a database such as DynamoDB, then you need permissions here. So I will create a new role. I give a basic name like Madrid role. And then I don't need to give any policy because I just need the basic permissions, so I don't need anything here. Now there's tags. Tags is just a key value that you can attach for example, for billing purposes. But there's some advanced settings that we will leave as default, but it's interesting to have a look at. So here's the memory that I was mentioning before. So here you can choose how much memory you want to give to the container that will execute this code. And the more memory you give, the more CPU power, the more I/O power you get. So imagine that there's like a server, we will cut the server depending on how much memory you give, and you get more CPU and more I/O. So if you have a function that is a little bit slow, you can give more memory and it will also go faster. And if you double the memory, so instead of 128 megabytes, I give 256, doubling the memory, you doubling the cost. But if the function is quicker, then you also reduce the execution time. So sometimes you can increase the memory, get a smaller execution time, the increase in cost is very little, and you get better performance. So play a little bit with it. So for now, for saying hello world, 128 megabytes is more than enough. Then we have the timeout. So if you execute this function and you make a mistake, like an infinite loop, the function will go forever, and you will pay forever to AWS for the execution of the function. So we don't want that, so there is a maximum timeout. When you reach this timeout, we will terminate the function. We already increased the maximum timeout. Today is 5 minutes, the maximum length of a Lambda function, and you can choose your timeout here. So this is only a timeout. So if you know that your function, for example, executes in 2 seconds, you can put 5 seconds or 10 seconds as timeout, because you will reach the timeout only in case of something strange happening. 3 seconds to say hello world, again, is more than enough. The DLQ is a new option that we launched. DLQ means that letter Q is a way in IT to say, when something goes wrong, I want to put everything that goes wrong into this queue so that I can process what's wrong afterwards. So if you, for example, trigger a Lambda function asynchronously when you upload a file, when you do something, you may have errors. We will automatically retry a function 2 times, but if for 2 times we get an error, the 3rd time we will take the input event, the input of the function, and we will put it into the queue here so that you can manually or even automatically process this queue and understand what's happening, why you are getting errors. You can use other AWS services here, such as the notification service or the queue service. Another interesting option is the VPC, the Virtual Private Cloud. Normally, Lambda function, they have internet visibility, so you can call any API available on the internet. But if you use AWS, you probably create your own virtual data center that is private to you. And this is called the VPC, the Virtual Private Cloud. So if you need to access resources that are inside your own virtual private cloud, like your own private database, you can just choose the VPC here, and then you can choose which subnet within your VPC to give connectivity to this Lambda function, and then you can reach your own private resources. And if you're here, you need also to think that this Lambda function will not have automatically internet connectivity. You need to provide from this subnet internet connectivity to the Lambda function using an app, for example. So for now, I'm not using a VPC because I don't need it. AWS X-Ray is a new service that we launched last year, and it's now in general availability, so everybody can use it. And it's in preview with the integration with Lambda. X-Ray is quite an interesting service. I will show you a quick demo, but the idea is that when you start to have microservices, lots of small components, it's not easy to understand what's happening. So if you have an error, where you're spending your own time. So with X-Ray, as the name suggests, we are tracing what's happening in a distributed application. And then you can have a map of what is happening, where you have errors, where there are where you're spending your time. So I have a sample page here from a sample application. No, it's here. So for example, this is an architecture with 4 components, and the design is automatically done by X-ray. So you just need to plug in X-ray. We will discover all the calls, all the modules, and we will draw the map. We call it service map of your architecture with the possible error where you are spending time. And this is something quite interesting when you start to go distributed. For now, I'm not enabling this functionality because it's a single function. You will not get some interesting information. Last parameter is KMS, is the key management service. It's a way to encrypt, to manage keys on AWS in a very secure way because we use anti-tampering hardware. So that means that if someone is inside our data center trying to get your keys, we will log what is happening, and final result, we will destroy the key before giving access to someone else to your own encryption keys. So it's very robust. And we use it for the environmental variables. So everything that you put in the configuration here, like your database connection, your users, is automatically encrypted. And we use a standard key for that. But you may create your own custom encryption keys with your own policy, like my keys needs to be rotated every month because I have a policy compliance. I want to create a role for someone that is able to manage my keys. So if you need to go more deeper, you can create your own custom keys. Otherwise, a default key is created for you, and it's completely transparent. So apart from this advanced setting that I didn't change, the only important thing is to give the handler of the function, create a role, and then you can go and create your function. This is the classical recap. Usually on AWS, when you create something, you get a recap just for confirmation, and I can create my function. Let's see if internet is working. Yeah, it's working. So okay, sometimes. Okay, congratulations, we created our first function, and we can start testing the function on the console. So I can create a test event. You remember the input was a name, and I can use my own name, Danilo. And this is standard JSON syntax, so it's a standard syntax to give parameters, and it's what Lambda is expecting. So I'm giving a name. I can now save and test. And wonders of the wonders, we get hello Danilo. And we get some nice information here. So here you have access to the logs. And here you have, we spent 18 milliseconds. And we use 17 megabytes out of the 128 megabytes that we gave. Probably this is the size of the Node.js interpreter. Let's test the other use case. So let's give an empty input. So there is no name. What should happen? Hello world. And we have. So we did also some regression. So now we have this very small function. It's there. It's all alone in the cloud. Nobody can use it, but actually it's available as an AWS API. So with an AWS account, I can reach this function, and I can call it from a web browser. So if I have some JavaScript running, not on a server, but on a client, like when you download a browser, a static page, this can use this function as a backend API. You can use it as at the backend of your mobile app, from wearables, from IoT devices, you can bridge it, and from other services. So we created a function that is like an API that you can call, but you need to use the AWS API for now. So you need the AWS SDK for security. These functions are designed to be stateless. So every time you invoke this function, you shouldn't expect to have a state that is kept there. So you should think of your function to be designed as stateless. Every time you trigger a function, you start from scratch. You need to get a state, use it, and eventually persist the state on other external repositories, such as a database like DynamoDB, or a file repository like Amazon S3. Thinking stateless is also a good practice from a development perspective. So I think this is enforcing a good practice when you design your application. What's interesting is that, as you remember, when I created the function, there was the possibility to create a trigger. So what happens is that my database, like DynamoDB, when you update something, can trigger another function. Or if I upload a file, I can trigger another function. So you can start chaining your logic to events. So I trigger a function that writes in a database, this triggers another piece of logic, that triggers another piece of logic. So instead of having a big, complex workflow to manage in your application, you start to have small pieces of logic that are triggered by events. For example, in my book, I use this for us to build a sample application, a sort of a poor man Instagram, where you share your pictures with other people. The idea is that you can upload a picture on S3, for example, and with the picture on S3, you can put your own metadata, like this is the author of the picture, is this a private picture or a public picture, all the normal metadata that you can put with some piece of content. And then S3, when you upload the picture, triggers a function that will take the metadata and write the metadata on a database, on DynamoDB. And then the database will trigger another function that will query the database, get all the pictures that the user can see, and prepare an index file, like a sort of a static index for what a user can see or cannot see, that is written back to S3. So when you log in, you always find an updated index as a static file of what you can see and what you cannot see. And this is the same trick that Facebook or Twitter does. So when you connect on the home page of Facebook or Twitter, they have a pre-computed index of what you can see, so that most of the access is pre-cached. They don't need to go on the database to build the home page. Only when you start to go down and see what's happened maybe in the past, they start to run queries on the database. This is very efficient. Otherwise, if every user goes on the home page and you start querying all the database in parallel, that would just require too much power on the database. So this is an example of how you can have chaining of multiple functions together. And if you think of this, you start to have a client here, a business logic here, and a data persistence layer here with database files. And it's not that different from normal architectures that we built for years. The only difference is the fact that you can trigger logic back and forth between business and data. So this is the main difference. And we can simplify this just grouping everything. And there's actually another catch, because you can also, from the client application, so from your mobile app or from your browser, go straight to S3 or DynamoDB, to the AWS services. You can use that. So you can, the example that I did before was using this approach. So when you upload a picture for a media sharing platform, you go straight on S3, and this will trigger the logic that will run and pre-build the index. So you have two ways of using Lambda function: straight, calling the function, or through another service that will trigger the functions. Make sense? So up to now, we always use the AWS API here, and this is working, but probably you want to decouple the client application from the backend implementation. For example, the mobile application, if it's a mobile application, is developed by a different team that doesn't know anything of AWS, or maybe you just want to expose to your customers that you're using AWS. So there are products that can act as what is called an API gateway. The idea is that you can model your own API using an HTTP design, and then this can be mapped to invoking functions or to invoking other AWS services. So you model your own API, like upload picture, download picture, get metadata of the picture, and this is transformed to invoking a function or even another an upload to Amazon S3. We have a product that is called the Amazon API Gateway, but think here of something that is really more generic. For example, we have another platform that is called the AWS IoT, that is normally used by client application running on very small devices, like sensors, actuators. And the AWS IoT platform can map from the IoT world using not HTTP protocol, but MQTT, that is a very lightweight protocol that can be used by devices running on batteries. So it's very lightweight. You don't need all the complexity of HTTPS. And from a small sensor, you can use this MQTT protocol, and this is transformed to calling function or other AWS services. So it's more of a concept than a specific product here. However, as I said, we have the Amazon API Gateway, and you can use it to create your own API. And what we did when we launched the Amazon API Gateway 2 years ago, almost now, was let's give complete freedom to our users. So we give the idea that, okay, you have an input, and then you can create some template that will map your input to what you want to pass to the function. And we use an internet standard. It's called Velocity Template. It's part of the Apache Velocity project. It's quite a complex syntax, but you can map any input to any function. It works, but it's quite complex, and we noticed that the customers were always doing the same thing, because at the end you get a few parameters in input and you pass these parameters to the function. So instead of doing that, we proposed a standard integration, and it's now the default when you use the API gateway with Lambda. It's called API gateway proxy integration, and basically when you get an HTTP request to the Amazon API gateway, everything is mapped into these standard values here. I zoom just a little bit, so you get the HTTP path of the URL, you get the HTTP method, is this a get, a post, the HTTP headers, the query string parameters, so the parameters in the URL, and you can also get the body, and you can also get a body that is binary, so it's encoded if in that case. And so the Lambda function will get this as event, and it must return this very simple syntax in output. So the HTTP status code, so this is the output of the function. You know, HTTP has status code like 200 OK, 301 move permanently. So this is the status code. You can optionally customize the headers of the request, like to set a cookie, and the body of the answer. So if you just fill this and give it as return instead of the hello world you saw before, you can create an API. So let's use this to transform the hello world example in an internet API that anybody can use. So let's go next. And this is still in the same repository. And I have the Gridix API example. So we can go here. Let's create, I go on function. Let's create a new function. This time, I select a trigger. When you select a trigger, you can choose from a long list of services that can trigger Lambda function. And for now, I choose the API gateway. You can give your API a name. This is just a way to group multiple APIs into a single logic for management. Lambda microservice can be a good name for now. Then you can choose a stage. Stage is a concept of the API gateway where you can have multiple stages for an API, like test, development, production. And if you create multiple stages, you can release like your changes in tests. And then if they are working OK, then you can just with a click or with a command line command say, move this change from test to production, from one stage to the other. You can also use stages to pass custom parameters, like my database password, as I said, probably is different between production and test, and you can set this at stage level so that every invocation will get the right password. And then there is the security. Normally, you can protect APIs in multiple ways with the API gateway because you don't want people to abuse your API. You can protect using our identity and access management service. We also have the concept of developer keys, access keys. For now, I just create a completely open API because it's just for fun. So this is the minimal integration that you need to do to create an API with a Lambda function. We call it greetings API. So hello as an API. I still use Node.js, and I can just copy and paste the code here. And this is a little bit more longer than before, but actually it's just boilerplate code. So if you see, we get the input event, and now I'm looking in the query string parameters if there is a name. If there is a name, I use it. Otherwise, I use word. I also look, this is something more than before, for an HTTP status parameters in the query string parameters. If there is this value, I will use it as response code. Then I build my response back, hello Danilo, hello world. And now I build a slightly more complex response. I say, this is the status code, so 200 OK is the default. I add a custom header just for fun, and then I use the previous response body as my body. So this is the response of my API. So there's a little bit more complexity, but it's very similar. Now I can just reuse the same role as before. So we should have the service role, Madrid role here. I don't change all the other settings. I create my function. And this time, it's faster. But I also get the integration with the trigger, and we get the URL of the API gateway. So now, it's not a simple API, but if you click on this, you would get this output, hello world. And if I go here and I add like a parameter, my name, this is the standard syntax that HTTP is using to pass a query parameter. So I'm just reusing that, and we get hello Danilo. So we now just created an internet available, highly scalable API with just a few clicks, and the reduced cost that we just mentioned before. So let's go back on the Lambda console. So you can monitor what is happening here with the monitor tab. You see how many invocations, what is the average, minimum, and maximum duration of your function, if there is any error. And here you have the straight link to CloudWatch to see the logs. And if you enable X-ray, you can also see the traces of your function. So this is a second evolution, but probably you want to do something more. So I have the final extension of this API that is using environmental variables. So log level, and then. So this is a slightly more complex example. And we can just paste the code here and update my function. And the idea is, let's use the environmental variables to set some parameters. So one thing that normally we do with code is, you don't want the same debugging, the same logging in development and in production. You want to set up a log level, and then you want more verbose logs in test and dev, and then less just the information in production, unless you have something to debug. So let's do that. So I'm replacing the code. Let me check that I copied the right one. Yes. Here. No. OK, so this is the new code. And what I do, I use an environmental variable that is called log level. And the log level can be error, warn, info, verbose, or debug. If I choose debug, I get everything. If I choose verbose, I don't have the debug information. If I choose info, I only get this kind of errors, warns, and info, and so on. So this is like my log level. And let's choose, for example, to go with debug. So I can write a log level here, and as value, I put debug, so I want all the information. And for simplicity, I created two functions here. One is called log when, and you say log when debug, log when is an error, log when is an info. And I also added another function that is called do when, and this is execute this code, the code that is here, only if the log level is higher than this. So you can add not just a different log, but you can do something different if the log level is different. How I'm using this? I'm just in the code using this. For example, here I have a log when debug to see I received this HTTP status. And what I'm also changing different is here. When I build the response of my API, I add also a log when. No, it's not here. Do when, sorry, it's here. So when I build my response body, I say hello world, hello Danilo. I also do when debug, so only in debug to the response body, I add an input parameter that contains all my input events. So I want to debug everything that this function received. So the output is changing if I go in debug. So I can now save and test this new function. And we don't need to test it from here. We can test the API. So let's trigger the API. And now you see, since I'm in debug, I don't get only the message, but I get also this input with everything that was logged. So it's very verbose and probably not so nice as before. I can just go back to my Lambda console and change the log level to be info. Save. And now if I reload it here, I removed the specific information. So this is a way to use environmental variables to change the behavior of your code. It's just a nice trick. Okay, so we saw lots of stuff. How can I start to do something more interesting than hello world? Because so they have lots of tools that can help you create interesting application. This is a tool for Python developers, since I was using lots of JavaScript. This is using the same syntax as two popular web micro frameworks in Python. They're called Flask and Bottle. So the idea is that you can just connect to HTTP routes the functions that you want to execute. And with the same syntax, you can just create a function, and then you can say Chalice deploy. Chalice is the name of the framework, and this will automatically do all the configuration on the Lambda function, on the API gateway, and you have your code. And there is a configuration file where you can change things like the stage. So it's a very, if you're a Python developer and you use Bottle and Flask, this is quite cool. There is the serverless framework. It's a more powerful framework. It can cover JavaScript and Python, and it's quite interesting. So if you are used to use text frameworks that are a little bit opinionated, like Ruby on Rails, these kind of things, or Express, this is probably a good way to start using serverless technology. We also have a reference application that is a little bit more interesting than my hello world. This was prepared for last year in Vegas when I met Juanca. It's a client application running using the Ionic framework for JavaScript, so it can run on a browser or in a mobile app. And it's a booking application when we have rooms to book, like a classical booking application. So here you see how to design the client front end in JavaScript using JavaScript, but also the Ionic framework, and the backend using Lambda function, the API gateway, how to protect your API using Amazon Cognito. It shows how to do user management, how to create different profiles of users, like basic users, administrator users that are more powerful in your application and have access to more resources in the backend. So it's a nice sample implementation. There's also a 1-hour video online that describes all the applications. So go here to get more information. And this is the way I explain what I do to my relatives, to my family. And this is a nice reference for serverless application. So you may remind that a couple of years ago there was, or it was last year, the European Football Championship in France. And David Guetta was in charge of the anthem, of the song for the event. And when he was asked, he said, I want to have lots of people singing with me in the final song. How many people do you want? 10, 100? He said, I want 1 million people singing with me in the final edit of the song. So this relatively small company in the UK, they're based out of Leeds, is called Parallax. They use the serverless framework to create a serverless application using Lambda and API gateway, where people could go, sing their song, and they would automatically store the output of the singing of every people on an Amazon S3 file. And then at the end, they took all the S3 file, they downloaded, they remixed it, and in the final edit of the song, there was all these people singing together. And the final bill, I don't remember the right number, the people from Parallax, they said it's like a few $100 was the total cost of the infrastructure for a very visible project used by lots of people during the championship. So this is a nice way to explain to someone that is not technical how you can use serverless and build something cool and be very efficient in your costs. Another question that I get is, okay, I like the approach, but now I need to rebuild everything because this is so different from what I'm used to do with my Java environment, my JavaScript or Python environment. We've seen lots of tools, some developed by the community and some also created by AWS after we saw this trend, to take standard application and map them to this new approach. So if you use Node.js with Express, we created this framework where you can take your Express application, embed it in it, and we will automatically deploy it to API Gateway and Lambda. And there's a similar one for Java, and there's lots of other tools similar to this. So if you have a normal web application, maybe there's already a tool, and this can very simplify your migration, and then you can eventually start to decompose your application into microservices and create smaller functions. Another question that I often get is, how can I go beyond the 5-minute timeout? Because 5 minutes is a lot for an API, but sometimes I need to do some processing. There's people doing things like MapReduce, very heavy backend processing with Lambda. Oh, this is a very simple trick. When I was working a few months ago, there is a new service that we launched last year. It's called Amazon Recognition, where you can give a picture and we will look into we will tell you what's inside the picture. We will tell you if there's people in the picture, what's the emotion of the people in the picture, are they happy, are they sad? And this works with simple picture for now. And the idea is, okay, how can I extend this to work with a movie where I want to process lots of frames with this service? So we created, we use Lambda, so you have all the frames of your movie, and you pass it in input to a Lambda function. You can possibly have thousands of frames, so you can't process all of them in 5 minutes. So what you can do, you get a list of things to do, you start taking the first picture to process, and you process them. And then you use the context. Remember, the function we're getting in input the event, and also the context that is telling you what's happening in the execution of the function. And one of the methods of the context is get remaining time in milliseconds. It tells you how many milliseconds you have left before the timeout will kill you. So if this time left is greater than some threshold, so I know that it takes like 1 second to process a picture, then if I have more than 3 seconds, then I process another item in the list. Otherwise, I take the remaining list and I invoke the same function asynchronously. So basically what I said, this is a Lambda function. I will call, from a Lambda function, I can call myself. The first function will terminate, and the function will restart with another 5 minutes doing the remaining processing. And since you're starting to process this with multiple Lambda functions, if you do this sequentially or in parallel, there's no difference in cost. So you pay the same. So you can process thousands of things in parallel, and you will pay exactly the same. So you can go very parallel. The idea is every work that you can split in chunks, you can process it in chunks. You can start how many Lambda functions you want in parallel or in sequentially, and just do your job. And what about larger applications? We launched a framework. It's called the Serverless Application Framework to describe the architecture of a more complex framework. I'm not entering into detail. This is released in open source with the Apache license. The idea is that you can have a text file where you describe, I want this function, the code is here, this needs to be an API, triggered by an S3 bucket, is a standard syntax, and you can model your application in a text file. When you do this, then you can use other AWS services to create continuous integration pipeline. So basically, you have your code like in GitHub or on code commit, our own managed Git repository, or as a file on Amazon S3. When you commit your code, this triggers a build process that will use this file to create the infrastructure. You can have automatic tests, and then you can deploy automatically in production. So you can really create a pipeline where you continuously deploy in production, and you can have a manual or automatic test process to validate your code. Normally, to set up this is not that easy, because you need to know a few of the AWS services that are here, like code build, code pipeline. So 2 weeks ago, we launched this new service. It's called AWS CodeStar, and it's a new service with no cost by itself, where you create a new application. You can also set up your team with all the people working on our application, and we will create all the necessary configuration to have a continuous deployment environment for your application. And we also have an agreement with Atlassian that will give you, without any cost, a Jira access, so that you can create also Jira to manage your bugs and your issues without any cost. So you really set up all your environment. I can just give you a quick look of it. So this is my management. So let's go on CodeStar. And with CodeStar, you can create a new project. You can choose what kind of project you want to use. It's not just serverless. It can be any traditional application. Like I want to create a web service, a web application, I want to use Ruby, Node. I can use Lambda or other services like EC2 or Elastic Beanstalk. So let's use Lambda and let's use Python. And you can create, for example, a Python web service. You give the project a name, like Madrid test. You create the project. Then you can link this to command line tools, or if you use Visual Studio or Eclipse, you can link this to your own development environment. So if you use command line tools, you just clone the repository. And now you have everything here. So you have, now it's building up, so it takes some time. This is an example that is already up. So you get the link to your application. So this is another boring Hello World application. You have your own continuous deployment pipeline. So in this case, I'm using code commit, but every time you commit your code, it will automatically rebuild your application and deploy the application in the environment that you choose. You have all the monitoring of your application. You can choose the branch you want to see the history. And you have all the information. You can also set up a team and configure the issue tracking using Jira. So everything is a single console. For a development team, I think it's really interesting. And as I said, there is no code in it. You only pay for the service that you use, like Lambda or code pipeline. For more complex workflow, we also release step functions. It's a way to model more complex workflows. So the example that I do usually is if you have a website like an e-commerce, normally you have some operations that are more critical, like the purchase operation is very complex. When you have an e-commerce website, when you buy something, you need to check the availability, the payment, you start the delivery. So you can model your workflow here, and then you can create smaller Lambda function for each step so that you don't create a very big application. And to model this workflow, we created a new state language. It's JSON-based, and it's available as an open source. So anybody can leverage this states language so that nobody needs to reinvent the wheel every time. X-ray I already mentioned for monitoring. And the last thing before I wrap up is that we are starting to thinking about running Lambda functions not only inside our own data centers, but really everywhere. And there is this project, it's called AWS Greengrass. It's currently in a closed preview, so you need to apply. And we will give you some software that you can install on an Intel server or even on a very small ARM server like a Raspberry Pi, so the requirements are very small. And this can act as a gateway with the cloud, and you can run Lambda functions and also do other things like messaging and caching. And even if you lose connectivity with the cloud, you can still run your Lambda functions locally and collect data locally. This is something that is used by the AWS Snowball Edge. This is a storage device that you can rent using our console. So if you want to upload data to Amazon S3 or to other service, to the AWS cloud, or you want to download lots of data and internet is not fast enough, you can order one of these. We will ship it to you. There is a Kindle here that is the shipping label. So automatically will come with the e-ink screen with your address. And then when you send it back, it will automatically be replaced with our address for shipping it back. And this has 100 terabytes of drives inside, and you can upload your data here and ship it back. Now you can use Greengrass to run functions. So there are customers, for example, that if you want to collect data in the middle of the ocean, you can bring one of these, go in your boat, collect from thousands of sensors, temperature, humidity, the water flowing, and you can start processing this information with Lambda functions, even if you are completely disconnected using Greengrass. And when you reach the port, you can upload the processed data to the cloud, and maybe the raw data, that is a lot more, you can ship it back, and we will ship you another one to use. If 100 terabytes is not enough, you can order more of them, and they will cluster, 300, 500. If you really need more, we also have the Snowmobile. It's the extension of it. It's 100 petabytes, and it's full of drives. You can't order it by mistake on the console. You need to contact us. Like the Snowball has arrived, the Snowmobile has arrived. And there's like lots of fiber connectivity because to upload 100 petabyte, it's not easy. But we have customer in mapping or genetics that they really have exabyte of data. I still remember when 1 exabyte was the estimation of all the data in the world. Now we have a customer with more than 1 exabyte. And you can use this to upload or download the data. And finally, we come to the edge. You remember when we created the first function, there was this edge. The idea is there is this project, it's currently in preview, it's called Lambda at the Edge. So we have a content delivery network, it's called Amazon CloudFront, where you can distribute and cache content when it goes to your users. So instead of having a central region, you have like 70 plus edge location like we have in Madrid, so that your user can download pictures and content very quickly because they are very close to the edge location, it's called, where you cache your content. Now you can execute Lambda functions there to do some final customization. So for example, if you want to just change the name of your customer in the top right, you don't need to do this change in the data center and then send it back, but you can do that in the edge location. We have a customer that for pictures, the way colors is rendered on devices can change depending on the quality of the screen. So iPhones, Android devices, computer screens, every screen has a different color profile. What they do, they can check the kind of device that is asking for the picture and transform the picture color so that it's rendered in the best output on the device. So it doesn't seem, so it's really interesting because if you, as a user, especially advanced user, they really appreciate the output. Another scenario is to do A/B testing. So if you want to release a new version of your application, instead of releasing this application to all your users at once, you split your population of users in 2 groups, a group and a B group, like a smaller group. You can release this only to 5% of your user, see how they work with the new version, if they like it from the log, if they increase sales, they increase interactions. And then if this works, then you can roll out the features to all your users. And Lambda at the Edge can help you do that very fast because you do that close to your users so that the latency is very, very low. So lots of stuff that we saw today, some very technical stuff, some less. I hope it was interesting. I think this is really important. If you start to use a cloud provider, don't think that you're renting servers, but think that you're using services because it's the right approach to use the cloud in the best way. Thank you.